Now a sample circuit is shown in the figure. We are going to solve this circuit using nodal analysis. And look at the circuit. The first step is already told you. The first step is to find the number of nodes in the circuit. So you can see here number of nodes. Nodes are a meeting point of one or two or more branches. You can see here this one node. You can mark it as 1, and this node 2, and this node 3. And one reference node we have to mark. I told you that can be taken as reference node as 4. And normally voltage at this node can be taken as 0. That is very important. Okay. So now this one is V1 node voltage at node 1 is V1. You can give node voltage at 2 as V2 and node voltage is node 3 as V3. Now next step is to mark the branch currents. So let us take branch currents. Take this as I1. Current flowing through 2 ohms as I1. Current flowing through these 2 ohms between V1 and V2 or node 1 and 2 can take as I2. And current flowing through this one is 1 ohms is I3. And current flowing through 3 ohms here it has taken as I4. And current flowing through these 2 ohms can be taken as I5. So individual names to be given: I1, I2, I3, I4, I5. And two sources are shown here. One is between node 1 and 2 it is 5 ampere, and between node 2 and 3 as 2 ampere. Two sources are given. So our first step is we have to now we know how many equations we have to form. That is 1, 2, 3, including this reference node is 4, and 4 minus 1 3. 3 equations we have to form. So now let us apply Kirchhoff's Kirchhoff's current law. Kirchhoff's current law at node 1. At node 1. Once if I apply, you can see sum of the incoming current in this case it is 0. You can see this is outgoing, this is outgoing, this is outgoing. Correct? So I can mark it as 0. Sum of incoming current is equal to 0. And sum of outgoing currents can be marked as I1 plus I2 plus 5. So 0 is equal to I1, I2 and 5. Now we can find what is I1, what is I2. So I1 is equal to the current flowing is 2 ohms, that is between V1 and reference node, that is 0. So V1 minus 0 divided by R, as per Ohm's law, V by R is your I. So V1 by 2, that is your I1. Next I2 is equal to between V1 and V2. So nodes 1 and 2. So it can be taken as V1 minus V2 divided by that particular resistance is 2 ohms. That is equal to 0.5 V1. So here also you can make it's just 0.5 V1. Okay. So 0.5 V1 minus 0.5 V2. So I2 is formed. So now we can simplify this. So minus 5 is equal to 0.5 V1 plus 0.5 V1 minus 0.5 V2. So it is equal to V1 minus 0.5 V2 is your first equal to minus 5 is your first equation. Now let us come to second equation at node 2. Similarly, you have to apply Kirchhoff's current law. Apply KCL at node 2. Once I come to here, sum of incoming current you can see here 5 ampere comes towards the node, and this current flowing from this current flowing through this 2 ohms also coming towards the node 2, and current I3 is coming out of the node, and current I4 is coming out of the node. So I can do like this. So sum of incoming currents are 5 plus I2, and sum of outgoing currents are I3 plus I4. So I can simplify this just like that. I can have I3 plus I4 minus I2 is equal to 5. This is my equation. So already for I2 I know the equation, 0.5 V1 minus 0.5 V2. Now I have to find the equation for I3 and I4. So what is I3? I3 is equal to current flowing through this node and this node. Therefore V2 minus 0 is again V2. V2 divided by 1 is V2. Similarly, I want I4. I4 is the current flowing between V2 and V3. So node 2 and 3. So I can have this I4 as V2 minus V3 divided by 3. So you can simplify it. So I4 is equal to 1 divided by 3 is 0.333. So 0.333 V2 minus 0.333 V3. So I can substitute this one that side. So I3 is equal to V2 plus I4. I4 is 0.333 V2 minus 0.333 V3, and I2 all I have given minus 0.5 V1 minus 0.5 V2. So now we can is equal to 5. So now we can solve this. So once if you take minus 0.5 V1 and we add all V2, 0.5 V2 plus 1.5 V2, so 1.83 V2. So 0.33 plus 1.33 plus 0.5, it gives 1.8, so 1.83 V2 minus 0.33 V3 is your next equation, which is equal to 5 is your next equation, that is equation number 2. Now let us come to the third equation. We are moving to third equation. So in third equation, we have to apply third equation at node 3. So at node 3, apply KCL. So some of incoming currents are, so in this case outgoing current. So here some of the incoming current from this node is 2, and again here you can have minus 2, so 3, because sum of incoming current is 5 and sum of outgoing current from this node is 2. So 5 minus 2 is 3. Okay, you have to note this one. So 5 minus 2 here plus 2. So once you take this side, so minus 2. Okay, so it comes 3. 5 minus 5 minus 2 is 3. And now in this case at node 3, incoming currents are I4 2 and outgoing current is I5. So 2 plus I4 is equal to I5. That is your next equation. Therefore 2 is equal to I5 minus I4. Now we can already we know the equation for I4 we have found. Now we have to find the equation for I5 in terms of node voltage. So I5 is simply I5 is equal to V3 minus 0 divided by 2. So V3 by 2 is 0.5 V3. Once you know this, now we can substitute here. So once if you substitute 0.5 V3 for I4, it is 0.33 V2, 0.33 V2 minus 0.33 V3. Okay, is equal to 2. So now it is 0.33 V2 plus 0.83 V3 is equal to 2. That is your equation number 3. Once if you know all these 3 equations, now we can put this. So the equation is minus 0.33 V2 plus 0.83 V3 is equal to 2. Now let us put the matrix format. So general form of matrix for node analysis is conductance matrix V matrix is equal to I matrix. So conductance matrix 1 by R things. So you can see here the first equation, the coefficient with V1. So you can mark here V1, V2, V3. So coefficient related with coefficient 1, I mean V1 coefficient related to V1 is 1 and V2 is 0.5 and V3 is 0. Similarly, in equation 2, coefficient related with V1 is 0.5 minus 0.5 and V2 is 1.83 and V3 is minus 0.33. And in equation 3, coefficient with V1 is 0 and here it is 0.33 and for V3 it is 0.83. Now we can mark the current values. For first equation current is minus 5, for second equation current value is 3 and for third one it is 2. So once you know all this, now you can find using Cramer's rule, you can solve this problem and you can find V1, V2 and V3. Once you know this, you can find branch currents, all I1, I2, I3, I4, I5, all branches can be found easily. That's all about your solution for the problem given.